All right, physics part two. We're going to solve some triangles. These are right triangles. We may move into when we need to non-right triangles and some other trigonometry, but for now, we're just going to use sine, cosine, and tangent. So remember SOHCAHTOA and all this stuff from math class. That's important now. We'll use this for projectiles. We'll use this for force. It's really important to be able to break down a triangle so that you can solve some physics problems. So we'll start with this one. The angles aren't too bad. When you know 2, you can get the third, right? And we know that they add up to 180, so I could subtract 90 and 30 from 180. I know that that's a 60-degree angle up at the top. And I need to solve for the missing side. So many times in physics, we are going to label things with an x and a y. Those are called x and y components. And we're going to break that 10. Okay, that's the hypotenuse. We're going to break it down into its components, okay, x and y components, and we'll use sine and cosine to do that. So we'll start off with the x, okay. If you notice, right, you know the angle in that corner, and so I'm going to relate those two sides, okay, to that 30-degree angle. So the two sides touching the angle, one of them's the hypotenuse, the other one is the x side. So I can say the cosine of the angle, right, gives me a ratio adjacent side over hypotenuse. The adjacent side, right, being x and the hypotenuse being 10. So to solve for x, I'm going to multiply both sides by 10. Those cancel. I get x equals 10 cosine 30. So I have to type in 10 cosine 30 on my calculator, and I'm going to make sure I'm in degree mode. We're not going to use radians much in physics. Okay, it is important to know what a radian is. If you don't know, right, you need to take pre-calculus. But and you'll get there. Take algebra 2 and you'll get there. And but anyways, let's just work in degrees. So make sure your calculator set to degrees. 10 cosine 30 comes out to 8.66. Okay, we'll just round it to the hundredths. I'm not going to be too worried about sig figs at this point. Okay, so 8.66, do your reality check. It should be shorter than the hypotenuse. Okay, and to get y, you could either solve the Pythagorean Theorem, okay, now because it's a right triangle, or probably preferred is to just use the other trig ratio, use the sine. So if I'm comparing this, and this, so compared to the 30-degree angle, y and 10 are the opposite and the hypotenuse sides. And if you look, right, so opposite and hypotenuse, the sine relates those two sides of a triangle. So I can use a similar statement and say, sine of the angle is equal to the opposite side over the hypotenuse. Multiply by 10 to solve for y. Those cancel. I get y equals 10 sine 30. Now, right, 30 is a nice common angle. Some of you know that trig ratio. You're screaming at me. The sine of 30 is a half. I know my unit circle. That's great. I didn't know all that stuff when I took physics in high school. Mr. Groom harped on me to take more and more math, and I ended up taking pre-calculus and calculus and all that stuff. But at the time, when I took physics, I didn't know that the sine of 30 was a half or 0.5. That's why I just relied on calculator, and that's okay for physics. In math, you will need to memorize a bunch of stuff and common angles, but for now, you just type it in. 10 sine 30 will prove to you. Comes out to 5, right? A half times 10 is 5. You could double check your answer. You could do 5 squared plus 8.66 squared, right? A squared or x squared plus y squared should come out to 10 squared or 100, right? A squared plus b squared equals c squared. There's your triangle. We've solved for every missing angle and all the missing sides, right? We'll do another one. This one we don't know the hypotenuse, so I could say let's just start with the hypotenuse. I'll call it h. We'll call this y. And let's solve for it with this, and this. So again, that's the adjacent side, and the adjacent side and the hypotenuse, adjacent and hypotenuse go with cosine. So I can say the cosine of 72 degrees, right, is equal to the adjacent side over the hypotenuse. Now to solve for the hypotenuse here, right, we got to get it out of the denominator. So this is where the wheels fall off for a lot of you when you algebra. multiply by h, divide by the cosine of 72. We get h equals 200 over the cosine of 72. So I can type it in. 200 divided by cosine 72 degrees comes out to 647. Okay, and that's a side, so h is 647. Okay, you could then, I don't know, let's go crazy. Let's solve the other one with a tangent. I've been avoiding the Pythagorean theorem, but let's solve for it. So let's say I want to relate, oops, I need a different color. 72, 200 and y, right? That's the opposite and the adjacent side. This is opposite the angle. This is adjacent to the angle, 72. And so I'm going to use tangent, right? TOA. So I can say the tangent 72 is equal to the opposite side over the adjacent side, which is 200. Multiply by 200. Get y equals 200 tangent 72. 615, right? 0.5 or 616. And then that missing angle you need to just subtract to find. So I've got the two missing sides. The missing angle would be 90 minus 72. So what is that, 18? And we've got that. All right. Before we come back to this one's a little force diagram. Let me solve one. Try to draw one in here. Oh, here we go. What happens if you know two sides and not an angle? So let's just solve it. Let's start with this angle in here. We'll call it theta. Theta is a common symbol for an angle. So let's relate the two sides and the angle. That's the adjacent side and the hypotenuse. So adjacent hypotenuse cosine. The cosine of theta is equal to 15 over 22. Remember, for sine and cosine, this fraction always has to be less than 1, right? So you can't have the big number on top for sine and cosine, right? The hypotenuse is on the bottom. So you're like, how do I solve for theta, right? If it bugs you that it's theta, call that x for a second. How do I solve for x? You're like, oh, crap. Well, right, that's a function, right? X is, being a function is being operating on that. So I need to cancel out that function. So just like when we were canceling out division by multiplying, like right back here, multiplying by 200, here, the inverse function of a cosine is an arc cosine or an inverse cosine. Probably, I like the word inverse cosine. So I'm going to take the inverse cosine of the left, and I got to squeeze this in here. I got to take the inverse cosine of the right. So that's really sloppy, but I've got the inverse cosine of the cosine, and now I have the inverse cosine of 15 20-seconds. So here, right, those cancel. I get x equals, and the inverse cosine, hit the second key, right? I have little shift key or second key. Inverse cosine of 15 20-seconds. So that's a 47.0 degree angle. So here's 47. 90 minus 47 is 43. So I now know those angles. And then the last side, let's use the Pythagorean theorem. I've been avoiding it. A squared plus b squared equals c squared. So 15 squared plus, we'll call this y. Y squared equals the hypotenuse squared. Short side plus short side squareds equals the long side squared for a right triangle. 225 plus y squared equals, what's 22 squared? 484. Subtract off 225. I get 259. Take the square root, and I get 16.1. Okay, so that missing side equals 16.1 units. Okay, so that's using an inverse trig function to solve for a missing angle, right? All right, last one. This one just has to do with a little triangle similarity. So say I've got a box on a ramp. We're going to have a lot of these. That's part of physics, is these force diagrams. We've got this object on a ramp. It weighs 25 pounds, and gravity is pulling it straight towards the center of the earth, right? Here's the magma in the center of the earth, right? All that iron core. Gravity's pulling it straight down towards the center. Okay, but I want to know, it's on this ramp. I want to know how much force is actually pulling down the ramp. We'll call that the x component. And how much is pulling perpendicular? I'll draw my little perpendicular symbol. How much is pulling perpendicular to the ramp? We'll call that y. Okay, well actually let's be really specific. We'll call this force in the x direction, and we'll call this force in the y direction. And you're like, Mr. Ford, those don't look like x and y, they're tilted. But if we define, and this is where we'll start kind of talking about this next week, if we define our axis along the ramp and perpendicular to the ramp, then we need to know the force in both directions. So imagine this is just a just a triangle. It's got two missing sides. It's got a hypotenuse. And you're like, but what's the angle? And you're like, okay, here's where all that geometry with all those parallel lines and intersecting, yeah, all the geometry stuff you never get. It like comes into play here. Well, you're like, the ramp and this are perpendicular. So if I know that this is 18, then it turns out this little angle in here is also 18. So that's 18 degrees. Those are similar triangles. Even if the ramp isn't, say this distance isn't 25. Say that distance is like, 2 miles. Okay, but it's at an 18-degree angle. And we know that this is 25 pounds. This is also at an 18-degree angle because we drew it that way. So I've got this triangle. I've got an 18-degree angle. And I need to find x and y. Force in the x direction and force in the y direction. So we can look at this. I'm going to try and circle the three things. Let's look at this. We'll do this and this. So if I look, this is the opposite side, and this is the hypotenuse. So I'm going to use sine. So I can say the sine of 18 degrees is equal to the opposite side over 25. And I can solve for fx, would be force in the x direction, would be 25 sine 18. Right? I multiplied by 25. So that one comes out to 25 sine 18, 7.73. And that would, if this was in pounds, right? So let's say the weight of the box was 25 pounds, then a 7.7 pound force would be pulling it down the ramp. Okay, and the other portion, this y portion, sorry, is going to be pushing against the ramp in a perpendicular force. So let's solve for it. Maybe you're like, okay, well that's the adjacent side to 18 because it's right next to that. So I can use cosine this time. That'll be force in the y over the hypotenuse. So force in the y is equal to 25 cosine 18. 25 cosine 18 is equal to 23.8 pounds. All right, so a lot of the force, a lot of the weight that's acting on that object is actually getting pushed back by the ramp. And we're going to talk about all sorts of things called like the normal force and all this. But right now, think of it like a triangle. We just solved 18. This was 23.8. This was 7.7. This was 25. So we solved those. We knew that this was a right triangle. And and then the missing angle, less important here, but that would be 72. So we solved it all the same, but you can start to see it's going to have some physics application. So you guys, go thank your math teacher. Like it's really cool how we will start to use more and more of this. So anyways, I went long. I'll leave a triangle for you guys to try, and good luck.